Okay, about this subject. First of all, you know that the name of the subject is thermal and hydraulic machines. Okay, this is the hydraulic machine. Means that, terrible, okay, we have to write a little bit better. We have to study machines that work with incompressible fluid, means water, oils, like, for example, pump, turbine, hydraulic turbine, but also thermal machine. Thermal machine means machines that work with fluid where the temperature can vary in the evolution. Means machines that uses fluid like gas, vapor, and like working fluid. So the first thing that you can understand that when we work with a machine, we are thinking to an element that is able to transform the energy from one form to the other one. And in the middle, we have a fluid. So our machine is, at the moment, like a box. A box where we have a flux of the fluid that goes in and a flux of fluid that goes out. This fluid can be, like I said before, water, so incompressible fluid, or gas, vapor, compressible fluid. And at the same time, it is able to subtract energy to this fluid in order to give this energy in a mechanical form. When we say in a mechanical form, means that we have a shaft that is rotating, able to provide, in this case, a torque. So torque provided by our machine and rotational speed are in the same direction. Therefore, with this machine, we are able to, as I said before, to subtract energy to our fluid, provide energy in the mechanical form to a shaft, and we say that we have a turbine or a motor machine. At the same time, we can have another type of machine where the fluid flows through the machine, but the energy of the fluid increases. It means that we provide energy to our machine, always in the mechanical form. That means with a torque applied at a shaft, but at this time, the torque and the rotational speed will be in the same direction, but is provided by the external. And the energy of our fluid increases. This is a machine like a pump, a compressor, so the first big distinction in our machine is machine that belongs to the category of a pump, turbine, so machines that increases the energy of the fluid, and other machine that turbine, motors, etc., that subtract energy to the fluid in order to provide energy that can be, for example, converted in electrical energy. This is the first big distinction. And we will have to study machine of the first type and the second type. What happens in the machine can be really different. Always we have to work in our machine in some way. There are two big different types of machine. Machine that we call dynamic, machine, or machine that we call net positive displacement machine. Machine, obviously. They work in a totally different way. Probably as simpler to understand how does it work a net positive displacement machine. Because you can build a machine like this with 4 instruments. For example, net positive displacement machine. I would like to show you how you can build a very simple pump, for example, or compressor belonging to this category. The only things you need is a syringe. So something like this. With a plunger that you can move. The syringe, obviously, as you know, there is a connection. You can take the fluid from one environment and send it to the other one. But you want to fill your syringe when the plunger goes down. So this is your suction environment. And in this phase, you want to have only a fluid that goes in this direction, but you don't want to have a fluid coming from the other environment, that is the delivery environment. Suction environment. So when you move in this direction, obviously, you try to take fluid from both environments, but you want to avoid fluid coming from the delivery environment, only from the suction. So you need a very simple device here, a valve, like a ball, no, that is near the hole. When you try to take fluid from the delivery environment, this hole will be blocked. Therefore, the fluid coming from this environment is able to come. When you go in the other direction, you have a fluid that goes out, is able to go in this environment because this valve can open, but also is able to go in this environment. We need another valve here. This valve is only able to provide a flux in this direction. Therefore, with the two valves, you are able to, going down, have a fluid that fill your chamber. Going up, you are able to have a fluid that goes in the delivery environment. So with a very stupid things that are a syringe and two valves of this type that you can buy, for example, in the shop for aquariums. No? These are backflow valve. They are able to give a flow direction only from left to right. You are able to realize a very stupid pump. At the same time, if you substitute the water in the delivery and the suction environment with air, you are able to realize a net positive displacement compressor because you are working with air. So in this case, we have a very stupid machine able to take fluid from suction environment and increase the pressure in order to be able to open this valve and send it to the other environment. So this will be the subject of a part of our subject. Let me say, this kind of machines are machines where you are able to obtain very high delivery pressure, but small flow rate. This kind of machine is useful in power plants for fluid power, where, for example, in your car, the pump for the injection system is a pump of this type. A little bit complex, but the basic idea is always the same. Two valves and one plunger that moves. You have a similar machines, for example, in the oil system, where you have to, for your car, where you have to increase the pressure of oil in order to send the oil to the bearings, etc. These are the net positive displacement machines. The other categories, as the dynamic machine, works by using the interaction between a fluid and machine in a total different way. In order to explain very simply the idea of this machine, you have to think to an airplane. Okay, you know that in the airplane you have wing, yeah, and the interaction between your wings and the air is able to provide a force that we call lift, able to balance the weight of our, this is mg, the weight of our airplane. So we have the interaction, the wings, the fluid, that moves around our wings, and you know that the pressure here as well as the pressure here has to be the same, but the fluid that moves in the upper part have to follow a longer path, and the velocity here is a little bit higher than the velocity in the lower part. It follows, by applying the Bernoulli equation, do you remember, that say that head along a streamline is constant, means that the sum of three different types of energy, the energy related to the position, the energy related to the pressure, the energy related to the kinetic energy, okay, the velocity, as constant. Okay? And B, the variation of zeta negligible. Being C higher in the upper phase, we have that being this term constant, the pressure has to be lower. It follows a force in this direction because the pressure in the upper part is a little bit lower than the pressure in the lower part, that in this case is able to take the airplane at particular elevation, depends of the position, etc., in order to balance the weight. At the same time, we have also another force applied to our wing, that is the resistance, that we have to balance with with the force provided by the motor. So with the motor, we are able to balance the resistance. At the same time, we obtain the lift that is able to balance the weight. Okay, this is the idea that we have in a dynamic machines. So we have a lot of small wings. But now they don't have to balance the weight. The idea is to have a rotor with a lot of these wings in the radial direction. The fluid moves near our blades, it's better to call them instead of wheels. We have small forces that are able to generate a torque with respect to our shaft. So this force, this lift that in the airplane is used in order to balance the weight, in our dynamic machines, we have the force that are able to move the rotor around the shaft. So are able to provide a torque. Or at the same time, you can subtract energy by using the interaction in the opposite direction. So you have to move your rotor in the opposite direction. And you always are able to obtain dynamic machines of able to provide energy to the fluid, pump, compressor, or subtract energy to the fluid, motors and turbines. Okay? So these are the general introduction to what we have to analyze in our course. We have to analyze this type of machines: net positive displacement machine, dynamic machines. In the first part of our course, we have to analyze machine alone in order to understand how do they work. Okay? In the first part, we analyze the dynamic machines, turbines and pumps. In the last part, in the third part, we will analyze the net positive displacement machine. In the middle, we have a path that is where your teacher is Ms. Nodira, that you saw before, that refers to the power plants. It means when we combine many machines in order to work together, we are able to have a sequence of fluid transformation, thermodynamic transformation, and usually transform the energy, the input energy, that is the energy provided, for example, by a fluid, by a fuel, sorry, by means of a combustion. The energy provided by water that fall from a very high reservoir to a lower reservoir. So transform this form of energy in mechanical energy. That means also electrical energy. So when we have to analyze this kind of power plants, steam power plants, gas power plants, etc., we have to analyze the cycle, the thermodynamic cycle, the efficiency of the cycle, and this part will be analyzed in the middle with Professor Nodira. So these are the main part of our course. In order to move in this direction, the first things that we need is to be able to work with thermodynamics law. Something about the basic fluid dynamics law and a lot of thermodynamics law. It means that we have to remember absolutely the first law of thermodynamics, that will be the, let me say, the main instrument in our analysis. We continuously have to apply the first law of thermodynamics. Then we have to apply also other relationships coming from the fluid dynamic, like the continuity equation, the momentum conservation equation, and the angular momentum conservation equation. I wrote continuity, but you can also call this relationship in another way, because also in continuity we have to conserve something. This is the equation for the conservation of mass. Mass conservation equation. And also the first law of thermodynamics is a conservation law. Of what? Energy. Energy conservation equation. There is another one in the middle, that is the second law. Is it a law of conservation? No. This law, what does it say? No enthalpy. But it doesn't mind, the properties are not important now. Now I would like to focus the concept. Okay. So it explain how does the energy is able to go in some direction and on in other directions. There are evolution direction that are natural. Other are not natural. It's impossible to obtain alone. So this is a law that analyzes the energy evolution. is a little bit different, okay? But let me say that this one and this are the most important in our analysis. Also this will be used, but it is very easy to use this one because we will use a particular form for this relationship. Momentum conservation equation is only useful when you have to analyze the interaction between fluid and forces. For example, when you want to analyze the stress of your machines. But this is not a goal of our course. Therefore, this is for force analysis. We have to know, but we don't use it a lot. And the second law, thermodynamic, can be very useful. We usually don't use it in order to make calculation, but in order to analyze what happened in our machines, natural direction, etc. So the first thing that I would like to do is to remember, to resume something about the first law of thermodynamics. And I would like to do this with your help. You studied this subject, is it true? Okay. So the first things that I have to ask you is, the first law of thermodynamics was written by my colleague with reference to two different systems. Do you remember the idea of systems? Okay. So the first things that we have to define, what is a system? A thermodynamic system. Give me an idea of a system, or explain me what is a system. A thermodynamic system. System is defined closed. Okay? So, correctly, your colleague asked, what kind of system? Because, there are two types of systems, closed and open. So, start with the word system means closed, usually. Okay, give me a definition of closed system. Sorry? It's a part of the environment that is under consideration. There's no mass interaction between the outside no mass change. Okay, this is a very good thing. There is no much change. So means that a thermodynamic system is an amount of defined mass. Okay? This is the first thing. And now also, as a meaning, your idea is a portion of the environment. But the first thing that you have to say is an amount of mass defined. It means that all the molecules in your system have a name. You are able to know all the masses. Only that ones. So this is a system. But it's not finished. This is a system. But a thermodynamic system is an amount of mass able to exchange energy with the surrounding. Okay, the energy can be exchanged in how many ways? Two ways. That are heat and work. What is the difference between the heat and the work? So both of them are form of energy that can be exchanged. But what is the difference? How does heat move? Sorry? Okay, it moves from one body to another body, but how? What is the mechanism that is able to move the heat? Temperature gradient, temperature difference. So, the energy that can be exchanged by means of heat required are different in temperature. This is the heat. The other one is the work. How does the work can be exchanged? What do you need in order to exchange work? Force and displacement. You need both of them. To have force is not enough. Because if you try to do work by pushing that wall, you are not able to move the wall. Therefore, you are not doing work. Okay? So, force is a requirement. Displacement is the other one. So, generally speaking, this is the work done by which kind of forces? Better. External forces, because come from the external. And the force, displacement, where the product, and here we have to apply everything, this integral, to the surface of our system, SS. You said forces equal pressure. It's not exact. Not only pressure. Because when you studied mechanical, fluid mechanics or structure mechanics, you said that in one point of your fluid, of your body, you can have the stress that can be whether, or better, probably you did something, representation of this type, a small volume, then you have normal stresses that are sigma xx, etc., or sigma 11, sigma 22, sigma 33. But there are also other forces, remember, that are the shear forces that you call tau, tau 12, tau 21s, etc. So, generally speaking, we have in one point, so here, not only pressure, but also the tangential force. And F, this force, refers to the whole amount of forces applied to the system. Okay? Then it's true. The main part, the most important part, is the pressure. Okay? From the point of view of forces. But when you write this relationship and you analyze a small portion of your surface, you have your surface with forces applied, that moves as consequence of the interaction. So this is the surface at time t. This is a time t plus delta t, a little bit later. And this will be our displacement. This is our force that is equal to P, the pressure, time the A, the small surface. So this is the small forces acting on this surface. And it moves by ds. So this quantity will be P dA ds. What is dA ds? The volume. Therefore, this can also be written like P variation of volume, because variation of surface, small surface, small displacement. This is the volume variation. So another way to write, but we have to analyze better this, because we have to complete, is, or better, this is not correct. This can be also written in this way, but with a small variation, or better, we have to add a small things. In this idea, force and displacement are in the same direction, okay? So the work is positive or negative? Positive, okay. But if I have a positive work, in my previous analysis, I have a reduction in volume. Therefore, dV will be positive or negative? Negative. So, the first relationship say positive. The second one say negative. We have to put a sign in order to be congruent. When the force is able to reduce the volume of our system, the force are doing a positive work, a work that goes in our system. These forces produces a volume reduction, so a negative variation of volume. It means that in order to have always a positive work, we need a minus. Okay? So, good, you remember the idea of closed system. Do you remember the idea of the heat and work? And let me say, do you remember the final relationship for our first law of thermodynamics, first law of thermodynamics for closed system? What does it say? Sorry? Repeat, please. What does it say, the first law of thermodynamics? The conservation of energy. It says, if you put energy in your system, the energy of the system increases, because it has to be conserved. So it says, you have energy that goes in your system, it doesn't mind which way, heat or work. This energy goes in, increases the energy of the system. This is the energy of the system. Okay? So the first law of thermodynamics say a very simple thing. If you put energy in your box, the energy in the box increases. Okay? The only things that we have to discuss a little bit is how the energy can be stored in your system. The system is made by mass. How many ways to store energy in the mass you have? So, the energy in your system can be stored in how many ways? You have a mass. Rotation? Radiation. What is a radiation? Potential energy of what kind? First of all, think to a mass. You have this mass. How many type of energy? After that. For this. You are mechanical engineers. Sorry, you would like to be. You have a mass. Potential energy. Okay. The energy of this body will be different by moving it with respect to the earth. Why? Why we have this kind of energy? Because we have a field of forces. So there is a sort of energy related to the gravitational force field that is related to the elevation of our mass. It means that if we want to move our mass from this point to this point, we have to provide energy, because the forces are in this direction, and we have to apply force in this direction in order to provide energy to our mass. So the first things of energy that we can store in our mass is the potential energy, the gravitational energy, that we can say this is equal to the mass g z. Okay? Another way to store energy in a mass. Position and, you said before, velocity. Okay? So, kinetic energy. We have a mass that moves in this direction with velocity c, and we know that we have a kinetic energy that is equal to 1/2 mc squared. E is the refer to the whole amount, so this symbol, okay? This is the kinetic energy. When we would like to increase the kinetic energy, we have to push our mass. By pushing our mass, we have an acceleration against the inertia force that are equal to ma. So we have to work against the inertia in order to increase the kinetic energy. And at the end, we are able to put also this. Okay? Other way to store energy. Okay, what is internal energy? The idea of internal energy is correct. But explain what it is associated to what? Eh? Okay, it is related to temperature, but why? I would like to see something in my mass. Sorry? So, your colleague suggests, in my body, I have molecules. Molecules vibrate in all directions. This vibrational energy is related to temperature. So, we have an internal energy that we call with U, related to the temperature. Okay? So, at the moment we are not able to write a formula for this. We will write. But this will be related to the vibration. So, we store energy in vibration of our molecules related to temperature, but also by changing the position in our force field or by increasing the kinetic energy, velocity. In our machines, there are always components that rotate around a shaft. So we have rotors. So when you have a rotors, something that rotates, there is another field of forces. Do you remember which kind of field? Forces that you are not able to see, but you say you are able to prove the effect. Which one? Centrifugal force, okay? Centrifugal force. So if you have a mass that rotates around a shaft at the rotational speed, the frequency omega, and let me say with radius r means at a tangential velocity u equal to omega r, you have a forces applied to the mass m equal to, do you remember? M omega square r, or with reference to the u. Okay, we have this kind of force. Now, so we have to put here also a form of energy that will be stored in a centrifugal force field, omega, and we have to give also a formulation like this one. Okay, this was for gravitational energy, this was for kinetic. The new one, because the other one you already know, this one, do you remember, or have you seen? Is very, very similar to the kinetic energy. 1/2 mu square. C is the velocity of the mass, the absolute velocity. U is the velocity, the tangential velocity around a shaft. But there is a little bit different. Remember, difference. Here we have a force in this direction. In order to increase the energy, we have to apply the force in the opposite direction. Also here, we want to increase the kinetic energy. We have to push with our force against the inertial force in the opposite direction. Now, if we want to move our mass to bigger rho, we have to apply a force in this direction. That is exactly the same direction of Fc. So they have the same direction. It means that the energy related to the centrifugal force decreases by moving from low radius to high radius. Here we have a minus. So in the other case, in case sorry, case 1 and 2, we have to provide energy in order to increase the elevation, increase the kinetic energy. In this case, we have to break our mass because it would like to go in the higher radius. So we have to do negative terms. So this is the relationship. This is the relationship for our internal energy. And at the end, we can write a few seconds, then we stop a little bit. The QE plus LE, horrible, equal to delta U plus delta E, kinetic energy, gravitational energy, energy related to the centrifugal force. This is the first law of thermodynamics. Okay? In the first part of the lecture, we have to remember how evaluate LE. Okay? So a little break. 10 minutes. So this is the first relationship that we have to apply. Okay? Few